There seems to be no difficulty in moving
13
around.
should have entered the Earth's atmosphere.
Of landing a man on the moon and returning him safely to the Earth.
When you hear the word NASA, what comes to mind? Is it the thunderous spectacle of a launch? A pillar of fire and smoke tearing a hole in the sky? Is it the iconic images of astronauts walking on the moon, planting a flag in the silent dust of another world? Or maybe it's the tireless, silent explorers we send to the outer reaches of our solar system. Robots dutifully sending back postcards from Mars, Jupiter, and beyond. Those things are all part of the story, of course. They are the hardware, the headlines, the tangible proof of ambition made real. But they are not the heart of it. Not really. Because NASA isn't just rockets and robots. It's one of the last places on Earth where people still try to do impossible things for the right reasons. In a world often driven by profit, politics, and power, this is a sanctuary for a different kind of motivation, pure, unadulterated curiosity. It's a place built on the foundational human need to ask, what if, and why not? The right reasons aren't about conquering territory or gaining a strategic advantage. They're about expanding the horizons of human knowledge for everyone. They're about understanding our own fragile planet better by looking at it from the outside in. They're about searching for answers to the most profound questions we can ask. Are we alone? Where did we come from? Where are we going? This is a mission not for one nation, but for all humankind. And if you've ever wondered what it actually feels like to live inside that mission, to chase the impossible every single day, this is it. We're going inside the mind of NASA. But what is the mind of an organization this vast? It's not a single consciousness. It's a sprawling, beautiful, chaotic network of thousands of individual minds, all firing in concert. It's the quiet hum of a supercomputer running orbital calculations. It's the passionate debate in a conference room over the best way to land on a frozen moon. It's the gut-wrenching silence in mission control during the 7 minutes of terror as a rover descends to Mars. It's a feeling of profound responsibility, knowing that a decade of work by thousands of people rests on a single line of code you wrote. It's the frustration of 1,000 failed tests and the quiet elation of the one that finally works. It's the unique blend of optimism and paranoia required to plan for every conceivable failure, while still believing in the possibility of spectacular success. This isn't just a job, it's a state of being. It's the relentless, exhausting, and deeply rewarding pursuit of a goal so far in the future you may never see it completed in your lifetime. Because the journey to the stars doesn't start with fire or metal or countdowns. It doesn't begin in a cavernous assembly building or on a launch pad by the sea. It starts in a much quieter, more intimate place. It starts with a thought, sometimes just a doodle on a napkin, and one person crazy enough to believe it might work. It begins with a question that lodges itself in someone's mind and won't let go. A flicker of an idea that seems absurd at first, then intriguing, and finally, essential. It's born from the courage to voice that idea out loud, to share it with a colleague, to risk looking foolish for the sake of a potential breakthrough. This is the genesis of every mission. Not a committee or a mandate, but a spark of human imagination. It's the belief that a telescope the size of a tennis court could be folded up like origami and sent 1,000,000 miles from Earth. The conviction that we can fly a helicopter in the thin atmosphere of another planet. Every monumental achievement, every giant leap, can be traced back to that first fragile moment of belief, a single person, a simple sketch, and the audacious whisper of, "What if we could?" Every mission begins as a question. How do we fly through the sun's atmosphere without melting? How do we land a car on Mars using a crane dangling from a rocket? These sound ridiculous, until someone at NASA says, "Okay, what if we actually tried?" That's the wild part. NASA's job isn't to have the answers. It's to build the answers. They literally prototype the future, one problem at a time. The vibe inside isn't sterile like you might imagine. It's messy, human, and loud. Everyone has opinions. Everyone argues. It's like a family dinner. If your family could launch things into orbit, Here's something they don't put on the posters. NASA fails all the time, on purpose. Before any spacecraft can earn its wings and taste the vacuum of space, it must first endure a trial by fire and ice and pressure right here on Earth. The engineers at NASA have a philosophy that might seem counterintuitive. To build something that can survive the harshest environment known to humanity, you must first systematically, brutally, and repeatedly destroy it. They literally break hundreds of prototypes before anything ever leaves the ground. This isn't reckless destruction. It's a highly controlled scientific process of discovery. They subject components to violent shaking on massive tables that simulate the bone-jarring turbulence of a rocket launch. They lock them in thermal vacuum chambers, cycling between scorching heat and cryogenic cold to mimic the extreme temperature swings of orbiting the Earth. They pull, twist, and compress materials until they groan, crack, and ultimately shatter. Every single failure is a success. Each broken part, each fried circuit, each catastrophic collapse is a lesson learned in the safest possible place, the lab. Because that's the only way to truly understand what won't break up there, by meticulously breaking it down here. There are no repair shops in orbit, no pit crews waiting at Lagrange points. Once a mission launches, it's on its own. Every potential weakness must be found and fortified on the ground, long before the countdown ever begins. This relentless pursuit of perfection through imperfection fosters a unique culture. It's a culture where failure isn't just tolerated, it's a requirement. One lead engineer shared a piece of wisdom with me that perfectly captures this spirit. He said, "If you haven't failed yet, you're not pushing hard enough." I love that. It reframes failure not as an endpoint, but as a clear indicator that you are venturing into uncharted territory, operating at the very edge of what's possible. It means you're not just rebuilding what's been built before, you're inventing the future. This mindset is a powerful blend of relentless curiosity and profound stubbornness. The curiosity asks the audacious questions. What if we make it lighter, faster? What if we use a material that's never been tried? The stubbornness provides the resilience to endure the inevitable answer, which is often a loud, expensive no from the laws of physics. It's the grit to go back to the drawing board for the 100th time, armed with the knowledge of one more way to build a starship. This fusion of intellectual daring and sheer tenacity is the fundamental reason anything ever flies. It's the human engine that powers the rocket fuel. After all the testing, all the failures, and all the fixes, there comes a moment when the work on the ground is done. The rocket clears the tower, a thundering testament to 1,000 corrected mistakes. But the celebration is short-lived. In fact, the real test is just beginning. Let's talk about what is universally described as the single most stressful moment in any NASA mission: the silence. The profound, terrifying silence that falls over mission control right after launch. For several minutes, as the spacecraft hurtles through the upper atmosphere, it enters a communications blackout. The telemetry screens go blank. The roar of the engines fades, replaced by an unnerving quiet, punctuated only by the hum of computers and the sound of your own heartbeat in your ears. In that void, every engineer, every flight director, every person in that room is forced to confront the same question. Did we find all the flaws? Did we break it enough times down there so it wouldn't break up here? It's a period of suspended animation, a collective holding of breath where the fate of years of work, billions of dollars, and the dreams of a species hang on a thread of radio silence, waiting for a single, faint signal from the darkness. After a launch, there's this period of radio silence. The rocket has done its job, the engines have cut off, and the spacecraft is coasting, alone, through the black. Down in mission control, a strange, almost sacred calm settles over the room. It's not a peaceful quiet. It's a heavy, compressed silence, thick with anticipation. The air itself feels like it's holding its breath. Hundreds of people, each a world-class expert in their field, are reduced to the most basic human state: waiting. They're staring at screens filled with data, or rather, the absence of it. Trajectory plots hang frozen, system health indicators are blank, and status updates just read, awaiting signal. Every console is a vigil. You've spent years, sometimes a decade, of your life on this. You've calculated every variable, simulated every possible outcome, and built a machine designed to withstand the most hostile environment known to existence. But in this moment, all of that work is in the past. The spacecraft is millions of miles away, a silent traveler on a path you plotted. You can't nudge it. You can't fix a problem. You can't speed up the immutable laws of physics that govern its journey and the time it takes for its first whisper to cross the void. All you can do is sit in that quiet room, trust your colleagues, and pray that your math was right. And then, it happens. It's never a dramatic explosion of sound. It's a flicker, a single data packet that appears on a screen, a status that changes from red to green, a tiny, almost imperceptible spike on a graph. It's the faintest, most beautiful sound in the universe, the carrier tone, the spacecraft's heartbeat. For a split second, the room is still frozen, as if nobody dares to believe it. Then, one person, the flight director or the lead engineer, confirms it. We have acquisition of signal. And the room just erupts. The years of tension, the sleepless nights, the personal sacrifices, it all comes pouring out in a wave of pure, unadulterated joy. People are cheering, hugging strangers, crying openly. It's this incredible, cathartic release, because that tiny, insignificant beep, a whisper of data from a machine hurtling through the cosmos, is a profound declaration. It says, I'm alive. I'm where you told me to be, and I'm ready to work. It's the moment a multi-billion-dollar project transforms from an abstract concept into a tangible reality. It means we made it. Against all odds, we actually did it. It's so easy to think NASA's about hardware, about the monumental rockets, the impossibly complex rovers, the gleaming satellites. We see the machines, and they are magnificent. They are monuments to our ambition and ingenuity. But spend 5 minutes with anyone who works there, in the moments after that first signal, and you realize the truth. NASA isn't about machines. It's about the people who dream them up. It's about the late-night arguments over a whiteboard, the shared cups of cold coffee at 3 a.m., the napkin doodles that become blueprints for exploring new worlds. It's about the trust you place in the person at the console next to you, and the collective belief in a mission that is bigger than any single individual. The hardware is just the vessel. The real exploration, the real heart of the endeavor, is human. It's the relentless curiosity, the shared passion, and the unbreakable spirit of a team of people who dared to reach for the stars and, for a breathtaking moment, touch them. These are people who could work anywhere. Tech companies, startups, universities. But they choose this. They choose late nights and tight budgets and constant risk because they believe it matters. They don't get rich doing this. They get something better. That feeling of seeing the impossible actually work. That's why NASA still matters. Not because it's perfect, but because it's proof that humanity hasn't stopped reaching for more. When you zoom out, literally, everything we've ever built, every voice, every photo, every idea, fits on this one pale blue dot. NASA's not just studying space. They're holding up a mirror, showing us who we are and what we could become if we just keep asking, what if? Inside the mind of NASA, the future isn't a dream. It's a work in progress.
The exploration of space will go ahead, whether we join in it or not. And it is one of the great adventures of all time. And no nation which expects to be the leader of other nations can expect to stay behind. But why, some say, the moon? Why choose this as our goal? Why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade.
It's one small step for man, one giant leap for mankind.
Expedition 12 Commander Bill MacArthur.
with a greeting for his Expedition 11 counterpart.
Because of your work, because of the ingenuity, dedication, and entrepreneurial spirit reflected in this room and throughout the American space enterprise, since the end of Apollo 11, we've forged incredible breakthroughs in our technology that have allowed us to go further, more safely in space than ever before. And let me be clear. The first woman and the next man on the moon will both be American astronauts.
Throughout America's story, there are defining days. Days when minds change, hearts fill, and imaginations soar.
10, 9, 8, ignition sequence start. 5, 4, 3, 2, 1, 0.
Doing what is hard and achieving what is great, that is what stirs humankind. That's what unites us. With inspiration and innovation, no Herculean effort is too large. No moonshot is beyond our reach.
It's one small step for man, one giant leap for mankind.
Then to take us further than ever before to Mars.
Swim 2 is moving in to deploy the flotation tower and 2 additional floaters.
Let us continue the quest to unfold this universe. And let us continue to find unity in our discovery. So together, let us continue to dream the impossible dream that now becomes real. Then let us traverse the untouched terrain of the once unreachable stars.